Hey everybody, here's our last video before I come back tomorrow. We've started this semester off by reviewing the idea of completing the square. Completing the square is a useful strategy that helps us solve some quadratic equations. However, it has its limitations. Completing the square was super cool, but sometimes it might not actually work. Or it would just be really difficult to get it to work. So a long time ago, mathematicians created this thing called the quadratic formula, which allows us to solve any quadratic equation. And we're going to work with that today. Little background on this is, why do we need a formula? Let's think about these two problems right here and try to solve them by completing the square. This first one right here should be pretty easy to complete the square. I'm not going to do the whole thing, but the idea should make sense. We learned that we can just take the term here. It's called b, technically. This is ax squared plus bx plus c. So we take b and we divide it by 2. 4 divided by 2 is 2. And then we square it. 2 squared is 4. So we know that 4 is the number that would complete the square. So we could rewrite this as x squared plus 4x plus 4. And now this would be a perfect square, but we change the equation. So to get back to this, we know that we would add 1 to 4 to make it equal to 5. And this is still equal to 0. This is a perfect square now. So we could rewrite this as x plus 2 squared after factoring it. That is this whole piece right here. We still have this plus 1 right here. So this is the process of completing the square. We know it works here. We're able to rewrite it in this form right here. And then we can continue solving. I'm not going to do that whole process though. On the other hand, what if we looked at something like this? At this point, there are a couple problems. This 2 right here is going to be in the way. It's going to prevent us from using this strategy the way we like it. Also, if we were to just look at this 7 to begin with, if I were to divide 7 by 2, well, 7 isn't divisible by 2. This is going to give me a decimal, or I could just leave it as a fraction. And then I'd have to square that decimal or fraction. So this would be like 7/2 squared. And then we're going to get 49 over 4. And I mean, come on, nobody wants to work with these massive fractions while we're working through a whole problem. It would get really difficult, especially if we had numbers even bigger. This 2 right here, what this is going to do is this would make us need 2 different diagrams. Like if we were to use the diagram method for this, we'd have to draw 2 diagrams and would have a bunch of squares, and you guys would hate your life with working with that. So completing the square does not work efficiently with problems like this, where b is not even. Even numbers can be divided by 2. So if b is not even, it's going to be difficult. And a is not 1. So completing the square works in cases where a, the number in front of our leading term, our leading coefficient, is 1, and b is even. So then mathematicians were like, well, what if we tried to solve the general form right here, ax squared plus bx plus c, to create a formula. Let's solve for x in this situation right here. Well, they did that. The work takes a little while, but it'll look something like this. Not expecting you to go through and do this by any means. In fact, we do this in pre-calculus. But after solving through this whole process, we get this extremely beautiful equation right here. This is known as the quadratic formula. In any case, after completing the square, x will be equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. This is the quadratic formula. So now the question is, how do we use that? What's going to look like when we actually go through and we use this formula that we have here? I'm going to zoom in and copy this formula. We won't do that actually. All right, so let's look at this example and try to use the quadratic formula for it. So again, this is what our formula looks like. It says x is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. You may have some familiarity with this from previous classes. In fact, you should have used this in Algebra 1. Well, in order to use this, we just need to identify what is b, what is a, what is c. We need to know what those numbers are. Well, looking at our equation, we can see those. This right here is a, b, and c. The important thing for the quadratic formula to work is this must always be equal to 0. If it's not equal to 0, well, we have to get one side equal 0. Make that smaller. There we go. So it must be equal to 0. So I can see now that a is 2, b is 5, and c is negative 12. And we can just substitute those into our formula to determine the solutions. So if I substitute those in, b is 5. So this will be x is equal to negative, there's this negative here, 5, that's b, plus or minus the square root of b squared. Again, b is 5, put it in parentheses, 5 squared, and then minus 4 times a times c. A is 2 and c is negative 12. So we have minus 4 times a is 2 and c is negative 12. Let's make sure this square root covers everything inside there. I'll close it off right there. And then we'll divide it all by 2 times a. And again, a is negative 12. Or sorry, a is 2, c is negative 12. All right, so we have now efficiently plugged in everything. A was 2. You can see that right here. B was 5. That showed up here and here. And then C was negative 12. We got plugged in that one spot. All right, so let's continue simplifying this expression now, and we will have our solutions. Can't do anything out here yet, so we still have this negative 5 plus or minus the square root of all of this. We can simplify what's inside of this square root. Square roots are like parentheses. It's a group. So 5 squared is 25. And then negative 4 times 2 is negative 8. And then negative 8 times negative 12. Think about that for a second. We know 8 times 12 is 96. They were both negative, so that becomes positive 96. And then this is all divided by 2 times 2, which is 4. And now we have that. Well, if we add now inside that square root, 25 plus 96 is going to be equal to 121. So we'll have 5 plus or minus the square root of 121. Still divided by 4. We know the square root of 121. 11 times 11 is 121. So the square root of 121 is 11. So this becomes -5 plus or minus 11 divided by 4. All right, and then at this point, I'm going to get two different possibilities. I have a plus or a minus. I need to break it up into both of them. My first possibility is -5 plus 11. So x is equal to -5 plus 11 divided by 4. Or x is equal to my second possibility, where it was -11. -5 minus 11 divided by 4. -5 plus 11 is 6 divided by 4. And this simplifies to 3 over 2. My other option would be to subtract. -5 minus 11 is -16, still over 4. And then -16 divided by 4 is -4. So now we have our two solutions. X is equal to 3/2 is one solution. We'll write it out. And then our second solution is x is equal to -4. So we have these two possible solutions to this quadratic equation. We were able to find it using the quadratic formula. Quadratic formula always, always, always works. All right, hopefully this example video helps. Remember that the quadratic formula is effective in cases where we have a leading coefficient, a, that is not 1, and the b term is not even. If a is 1 and b is even, completing the square would be pretty easy. But if not, go for quadratic formula. All right, hopefully this helps. See you guys tomorrow.